we have a precipitation reaction. So let's go and do the whole process. 1 volume of 0.1 molar sodium phosphate is required to precipitate all the lead ions from 150 milliliters of 0.25 molar lead nitrate sample. The first thing we're going to do, we're going to go ahead and we're going to separate the sodium phosphate and the lead nitrate into their ions because we need to actually write a balanced equation. So sodium ions and phosphate ions, so this is a 3 minus. Lead is 2, they gave it to us right here. And we have nitrate, which is just negative. All right, like I told you in class, I need you to switch them because this is a precipitation reaction and they say it right here, we need to get a solid. So now we're going to get sodium nitrate. Nitrates are usually soluble except for a few exceptions. So this one is going to be in the aqueous solution. Lead phosphate. Notice that the charges you need to actually come up with a neutral compound. So we are going to need 3 leads and we're going to need 2 of the phosphates. And the lead phosphates are actually insoluble, so this is going to be your solid. This is going to be your precipitate. So we're ready to write our equation. So we have sodium phosphate, soluble, so it's aqueous, reacting with lead nitrate, soluble, so it's aqueous, forming our solid. So again, put the solid in there, that's your precipitate. And we're also going to get sodium nitrate, which is soluble, so it's going to be in the aqueous solution. All right, we need to balance the equation because, for example, we have 1 lead here, but we have 3 on the other side. So go ahead and practice your balancing, but at the end, we're going to have 3 of the sodiums. We're going to have 3 of these, and we're going to have 2 of the original phosphates. So now we have 6 and 6 sodiums, 2 phosphates, 3 leads, 3 leads, and 2 of the nitrates. 6 of the nitrates. Sorry about that, 6. We're ready. So let's see how much lead is in the solution that they give us. And we're going to precipitate all the lead that we have. So first, give me the moles of lead. Notice what I did. I changed the milliliters to liters. You move the decimal point to the left when you're going from milliliters to liters. And I'm going to multiply by the molarity. So each liter of the molarity gives you the moles of your lead nitrate. We balance the equation, so we know that 3 of your lead nitrates are going to actually just make only 1 of those. Oh, hold on. We need the sodium phosphate, so 3 of these reacting with 2 of those. I apologize about that. 2 of the sodium phosphate. And the solution of sodium phosphate is 0.1 molar. So I want to have the moles down here. Okay, I like to always make sure that I cancel my units. The last unit is the moles, and I am left with liters, so that's your volume. So you plug all that into your calculator. That gives you quarter of a liter, 0.25 liters. If you wanted to go from liters to milliliters, now we're going to move the decimal point to the right 3 spaces. So that is actually 250 milliliters of your sodium phosphate solution.